This video, I am going to do question number 3 here. In the previous video, I did 1 and 2. So we'll scroll down to here. So this example is one for which I'm going to show you how we can integrate sometimes with respect to y instead of with respect to x like we did in the previous 2 examples. The other thing that I like to point out is that the x-axis is the line that goes like this, side to side, so that is y equal to 0. So I would like you to plug these 3 into your y equals screen, and I will do the same. Okay, so I've got 2x, 2 minus root x minus 1, and 0. One thing I notice here is that this is black. For me, my axes are black too, and I want to make sure I can see that thing. So I'm going to go over here and select that and change the color. So if we go like this, we'll do magenta. And then I can scroll down and hit OK. The second thing that's going to happen here is that I haven't fixed my window from the previous question that we did. So I'm going to show you a trick. A lot of times you hit graph and you're like, oh no, I have a bad window, or I left something in there, and it takes a really long time for the graph to graph, and it wastes your time. In order to save your time, what you can do, if the graph comes up and it's wrong and you need to get another window and fix that, you can hit this on button in the middle of when it's graphing. So I go like this, and it's like, oh, stop, right? And what it did, I had to do that really quickly because this on the computer goes fast. It stopped that y equals 0 from graphing. So there's not the little like spinny circle up here. So I can, like here, the window's not good. So I'm going to go back to my y equals screen. And as always, I'm going to do a zoom what? You said it. Good. Zoom 6. So here's my zoom 6, y equals 2x, y equals root x. And then there's that y equals 0. You can see my region here. Again, as with the last one, I'm going to do a zoom box. So zoom 1. I'm going to go down right to the left. Yeah, left a little bit, down a little bit. I always like to have a little bit of extra space there. So I'm going to go like that. And then I'm going to go over past where the red line clearly goes below the magenta and up to here, above that intersection, and hit enter. Boom, boom, go like that. So you can see that my region is this right here. I think it's pixelation right here. Let me check. I think that looks like it's at 1 second. Calc. I'm going to do value. And then I can hit x equals 1. Enter. All right, there's 2x. It goes through x equals 1. And then if I go over, whoops, not over. Second calc value 1. Enter. If I hit the down arrow, it'll take me to the red graph. And notice that it says x equals 1, y equals 2. It's the same thing as the blue one. So just with the way that my graph is graphing it here, TI does this sometimes. It makes it look like there's a gap, but there's not a gap there. If I wanted to check what the other one is, it's y equals 0 down here. So you can see the region right here. And I'm actually going to take a screenshot of this region and throw it over into the other app that I have so that I can talk about how we're going to do this integral. So here's 2 graphs of that region. Y equals 2, actually I'll label. So if I wanted to do a dx equation, I would always, whenever we do dx, we do top minus bottom. If I do top minus bottom here, my top is the blue. And then if I do top minus bottom, if I do top minus bottom over here to here, boom, it's the red. So what I think you should see is that if I do that, I actually have to split this into 2 regions. I need to get this integral right there. So that guy, or that space there. And then I need to get this integral here. So I would have to split it into 2 integrals. And honestly, for this one, it's not that bad. But sometimes it gets really complicated or even impossible to do that split or to integrate with respect to x. So what I want you to recognize is if I come over to this one, and if I do right minus left, then in that case, it's always the red minus the blue there. And where would I do it from? I would do it here, I would do it here, I would do it here, I would do it here. I would do those all the way up. So I would start at my y equals 0, and I would go up to this y, which I think we figured out was 2, and actually it's right there. I would go to 2. So I would start at y equals 0 and go to y equals 2. Those become my bounds. So if my bounds are y's, then I'm integrating with respect to y. So in this case, it becomes possible and easier, because I only have to do one integral, to integrate with respect to y. So let's do area equals the integral from 0 to 2 dy. And like I said, I got to take the bigger one, which is further out on the x-axis, subtract the smaller one, which is closer in on the x-axis. So what am I doing? I'm doing right minus left. So what previously was integral of top minus bottom now becomes integral of right minus left. So next thing I want to point out, this is an x-coordinate, x red, and this is an x-coordinate, x blue. When I'm doing, I'll erase all this junk. When I'm doing that bar right there, when I do that right minus left. So if that is the x-coordinate, because it's the side to side, right? You know, this would be like x equals maybe 2.5 or something like that. And this would be x equals maybe like 0.4. So I would do the 2.5 minus the 0.4, and that would be what I would be integrating. That would be what's inside of this integral here. So what I'm trying to get at is that I need to get this equation right here into an x equals form. And I need to get this equation into an x equals form. So the blue one's actually easy. If I start with y equals 2x, I can solve for x and get x equals y over 2. So that tells me that this here is x equals y over 2. And then when I solve for this one, I've got y equals 2 minus root x minus 1. When I solve for this one, I'm going to move the root over. That gives me y, or sorry, not move the root over, move the 2 over, y minus 2. Then I will negate everything. That makes this negative and this positive, equals root x minus 1. I can square both sides, and I'll write that as 2 minus y because it's easier. Squared equals x minus 1. And then I can move my 1 over and get that x is equal to 1 plus 2 minus y squared. You might be able to do that, all that work in your head, and that's totally fine. But that is an x equals equation for the right side. X equals, what was it? 1 plus 2 minus y squared. So when I do my integral, I'm going to do the integral from 0 to 2 of what is the right? It is 1 plus 2 minus y squared minus, and then I get my y over 2. I don't have to use parentheses because the y over 2 is just one term. dy. Now, if you weren't convinced with my explanation earlier about why we need an x equals for this equation, I hope that you can see it in another way. So usually, like these integrals up here, I'm integrating with respect to x when I have x's in here, and these are x values, negative 2 to 2. Come down here. I'm integrating dy, so my y values, I start at y equals 0, I go up to y equals 2. I need to have y's in here for my equations. If I have x's in here, then I can't integrate with respect to y because the x and the y are different variables. So one way to think about this, and this is a good way to think about it, is that I need y equations in here. So, because I'm integrating with respect to y. So we're going to go and solve these guys for x. And remember, I always do the right minus the left. Some people will flip that. So Now what I'm going to do is type this into my calculator. So we go math 9, 0 to 2 of 1 plus, open parentheses, 2 minus, and now there's a couple ways we can do this part. I can choose alpha y close squared minus y, whoops, not, minus alpha y over 2 over here, and as long as my variables match, do alpha y again, then hit enter, it gives me that. Again, I can math frac this thing if it's a multiple choice, and it tells me, oh, that's 11/3. I'm like, sweet. Now, you probably saw that I made a mistake there for a moment, and I typed an X there, and I just changed it to a Y. I used these Y's here because I wanted it to match what we just did. But really, the calculator doesn't care if we have Y equations or X equations. It's just going to calculate this integral for us. So I actually would prefer just to use the variable that's easier to get to, which is this X if I hit that button right there. So notice this integral is exactly the same as that one, except for instead of X's, it has Y's. And if I hit enter on this, bam, it gives me the same thing. So I think it's actually good for me to show you the Y's so you don't get confused with why I was doing Y's and then suddenly X's, right? But just know that we can use whatever variable we want on this integration when we are doing it in the calculator. So my answer for this one is 11/3. And I would have gotten the same answer if I had split it into two integrals, but sometimes we can't split it into two integrals, and I can do it with one integral with dy, and it works out just fine. So hopefully you understand how to use your calculator a little bit to find problems, find area for problems like these, and you can do some on your own. See ya!